Hey everyone, welcome back here to Techstrong TV. I haven't had the pleasure of having this gentleman on. It's got to be a couple of years, I bet already. Bart Giordano. Bart is the president over at RUCKUS Networks. We're happy to have him back. Hey Bart, how are you, man?
I'm doing really great, Alan. It has been too long. So thanks very much for inviting us back into this forum.
You know what? Don't make it like it's my fault. You could have come back anytime. Just drop a note and say, hey, I got something to talk about.
You
But
bet.
thank you. Thank you for coming. Uh, Bart, as I mentioned, you're the president over at RUCKUS. We're going to get into RUCKUS in a second. But before we do, give folks a sense kind of how you wound up to be president here, what your career path has been like.
Well, thanks, Alan. And again, thanks for having us on to TechStrong. So I've built a career here in Silicon Valley over the last, gosh, I hate to say 25 years now.
I get it. Yeah.
Exactly. I actually started off as a software engineer, and as my career evolved in that realm, and I started interfacing more with product managers and others, I got really curious about the front end of businesses. I started off writing software at Cisco and transitioned to the semiconductor industry, which is where I really cut my teeth in wireless. And ultimately joined RUCKUS to lead their business development organization. That was almost 11 years ago now. And
Wow.
throughout my career at RUCKUS, I've had the opportunity to lead sales, run product management, and I've been general managing the business for about 4 years now, and it's the best job I ever had.
Good for you, man. Good for you. Bart, did you ever think hardware would be as sexy as it is again?
Well, I think the reality is hardware is a very important part of the story, but what's happened is companies have evolved to full stack solutions. So we sell a lot of hardware. What makes the hardware really fantastic and what helps us deliver solutions that really solve customer challenges is the hardware, the firmware running on that hardware, the applications in the cloud to manage really complex environments, and now incorporating artificial intelligence into that in order to automate a lot of network management. So it's the full stack that comes together to solve business problems for our customers that we call purpose-driven networking at RUCKUS Networks.
Very cool. I think there's a point there that bears kind of sharpening up a bit, which is you could have the greatest hardware, you could have the greatest semis, you could have the greatest chassis platform, whatever. If you don't have the software stack
Yeah.
optimized for it, it just doesn't, no pun, it just doesn't compute, right? It just doesn't work.
Yeah.
And that software stack, depending vendor to vendor to vendor, there's always an element of kind of, let's call it in-house
Yeah.
software, right?
Yeah.
And oftentimes today, that in-house software, a lot of the hardware vendors are open sourcing to get it into the hands of as many people as possible. And then there's the ecosystem that develops around it.
That's
And
right.
that's really what separates a lot of the haves from the have-nots, right? How big that ecosystem, how deep it is.
Yeah, our
Uh,
philosophy at RUCKUS has always been around openness, right?
yeah,
So we believe, like to your point, a lot of the value in the solutions we bring are going to be derived by the APIs at the top of our stack that will allow us to fit into our customers' existing workflows and infrastructure environment and enable third parties to bring their own value based on the telemetry we can give them out of the network. And our philosophy really is, if you're going to add a feature, write the API first.
yeah.
We're a very API driven organization, and we want you to be able to get the full functionality out of that full stack from our APIs.
Great. You know what, Bart? I realized we jumped right into it here. We didn't even kind of give Ruckus a proper introduction. I'm assuming a lot of people out here have heard of Ruckus, are very familiar with Ruckus even, but I'm sure there's a lot of people who aren't.
Certainly.
So why don't we get everyone on an even footing here, Bart? Give us kind of the Ruckus story, if you will.
Yeah, so Ruckus is a 20 plus year old company now. We celebrated our incorporation after 2 decades in June of 2024. We started as a Wi-Fi business, an enterprise Wi-Fi solution that solved a very unique problem of distributing high definition video around a home. Before that was a use case that we all took for granted. Obviously, our
Hmm.
business has evolved considerably. We are a full-fledged enterprise networking portfolio today, both enterprise Wi-Fi, campus switching, and then, as I mentioned, an entire software solution stack on top of that that's now AI-driven, that is solving some of the toughest challenges in enterprise networking. We tend to be very focused on vertical market segments where we think our value proposition resonates, where the problems are the toughest. That's sort of where we really shine. So you think of places that struggle with extreme user density, stadiums or arenas or airports, or networks that have very dynamic physical environments, a factory or a warehouse where things are moving around quite frequently, and you can't make assumptions on the day you install that network of what it's going to look like tomorrow. And so you have to have an adaptive, resilient system that's able to perform under those dynamic and demanding conditions. And that's where Ruckus really thrives. We serve anything from a smart home to a higher education campus to a university to some of the largest venues in the world. We do a lot in municipalities where they're deploying Wi-Fi, for example, on the streets of New York City. So really challenging environments. That's where you want to select Ruckus. That's where our platforms tend to shine.
Excellent. Excellent. Look, you can't say it because you work there, but I can. For me, and this is going back before I started, Techstrong, I was, 12 years ago. This goes back to when I was at Still Secure and another startup that I had founded. Really, the way the kind of the Wi-Fi in the office kind of shook out for us was you could play with a lot of these solutions that, let's face it, they're really home solutions that you're using in
Yeah,
an office. And I'm not naming names, and it's not that they're bad. Today's meshes and Wi-Fi 7s and all that, we've come a long way from back in the day.
yeah,
But if you wanted to get an industrial Wi-Fi solution, right, that is going to be reliable, and people aren't going to be wasting their time,
yeah,
reattaching, renewing, and all the other stuff. Ruckus became kind of the gold standard for office grade, enterprise
yeah.
class Wi-Fi. And
Yeah,
that even if you were in a hotel sometime, any kind of commercial setting, it
yeah. I
really
appreciate you
became,
calling that out. I think Ruckus was really born out of serving largely guest-facing public Wi-Fi networks, which have a
yep,
very discrete problem to solve, maybe from even a traditional carpeted office or corporate environment. In a corporate environment, typically you're dealing with very symmetrical RF space, not a large density of users, right? Particularly today,
yeah,
right? You
yeah.
don't get everybody
No one's
coming
in
into
the
the
office.
office,
Yeah.
and you have an IT organization that is actually controlling the devices that come on that network. And your users tend to be fairly sophisticated. Compare that with a hotel or out on a city street, or in a classroom where you can't make any assumptions about the sophistication of your users. You're dealing with a very dynamic environment. You're going to see every possible conceivable device ever made with Wi-Fi connectivity come onto that network. So you can't make any assumptions about the nature of the devices you're going to see. Some of them might
Or
be
the nature of the
20
users,
years
Bart.
old. Yes,
Because some of
exactly.
those people are just devious and they just want to figure out how to get around the policies or whatever, right?
Devious or not technically sophisticated.
Well,
And it just
that's
need
the other strength. You have
yeah.
very technically devious people or innocent, newbies. Yeah, it runs the gamut, I
and it
guess.
just and it just has to work. So Ruckus was really designed for that case where the environment is extremely dynamic. You're dealing with a large diversity of users, periods of extreme high density, and you need to bring carrier grade and enterprise class reliability. And so when you solve for that, almost everything else seems simple by comparison.
Absolutely. Look, I remembered in the early days of Wi-Fi, and I traveled most of my life, right? I'm like you, we all, it was 50-50 in a lot of hotels, right? Whether
Yeah,
what they would tell you, oh, you're in this room. Well, the WAP for that's really down far. We may have
right.
to transfer you to another WAP. It wouldn't automatically move you from WAP to. Thank God for companies like Ruckus who kind of made
Well, and
that
that's really how we made a name
painless.
for ourselves because um I mean, you take it for granted today, but if you go to
Yeah,
a hotel property with your family, and I've experienced this, and your kids are complaining the entire week about how they can't get on the network and sort of ruining the vacation, and now your wife's a little bit upset that the kids aren't happy, you're probably not going back to that property. And more than likely, you'll go on to TripAdvisor or one of these other um, platforms and complain about it, right? Which is the
yep,
death knell for a hotel property. And the general
yep.
manager there, who's measured on guest satisfaction and loyalty. And when we started off in the hospitality space, we were actually able to correlate the installation of a Ruckus network with a market increase in the guest satisfaction at that property. So I think you've hit on something
That's real deal
that
right
we've
there. Yeah,
all experienced before.
yep. Hey, Bart, I want to jump into the topic of discussion today, but before we do, people who want to find out more about Ruckus, maybe there's some hotel operators out there right now and saying, "My God, where have you been? I need this." How do they get onto the Ruckus sort of on ramp here, if you will?
Yeah, very very simple. RUCKUSnetworks.com, or you can find us on LinkedIn, on X, on Facebook, any of the social media platforms. We're out there, but RUCKUSnetworks.com is a great place to start.
Excellent. All right, if it's okay with you, Bart, I want to kind of pivot a little bit and talk
Please.
about you guys recently announced your Pro AVICX switch portfolio with AV enhanced update to management platforms. Look, those are, that's some technical jargon we threw out there, but what's it mean?
So, when I was growing up, I was always tinkering with electronics, and I was the one that would set up the VCR for the family and get the TVs connected and figure out how all the remotes work. And back in those days, there were and subsequently many different standards applied to connecting AV equipment. You had RCA jacks for connecting video equipment, and you had these stereo jacks for connecting audio equipment. And then that evolved to standards like HDMI. And you would end up with like 50 different cables coming out of the back of your TV, depending on what you were trying to connect. And if you had to do that over long distances, it became pretty challenging. More recently, what's happened is a lot of those standards have converged onto running over traditional IP networks. And so there's this convergence happening in the audio video industry where they want to take advantage of the fact that every building, every facility, every venue has an IP network today because they're providing connectivity for lots of different services. So as that convergence is playing out, you have traditional AV folks who are maybe not as familiar with IP protocols and networking standards that are now thrust into this world of running, um, high definition video and very low latency audio over a traditional IP infrastructure. And so our goal with the introduction of the ICX Pro AV line is to really dramatically simplify running these traditional AV protocols over the corporate network. And so what we've done is we've configured kind of an out of the box experience, plug and play, if you will, so that if you want to run 4 and 8K video over an IP network and you want to run really high quality audio, you can do that without really intimate knowledge of networking itself. And that really is the advancement that we've made in our Pro AV line, is enabling AV professionals to leverage IP networking to move very low latency and very low jitter audio visual protocols over these networks.
Look, I'm a bit of a power user. I admit it. My
Right.
name's Alan and I'm a power user. My home has over 100 IP addresses. Like I'm going to wind up using a C class myself pretty soon. But, because I've got 20 something, I think I got 27 Sonos devices.
Right.
So I actually have a sub network of just Sonos running underneath my SSI, my regular Wi-Fi network.
Right.
And then I Ethernet into my TVs, but I actually Ethernet into my streaming devices usually, and then HDMI from the streaming devices to the TVs, because I use a
Right.
lot of Apple TV and all that stuff. I'm not your typical home user. Let's put it at that. And I have 8K TVs, I have 4K TVs, and I'm, in Dolby Atmos, and then any kind of new, things out there. I live this life, right? I'm almost my own campus in my own house, but it's so important because the last thing you want is to have all of that great of equipment and you got a fuzzy picture right in the
Right.
middle of the Super Bowl. That's just not acceptable.
Right.
And and whether we're talking about it at my house or I'm talking about it at a restaurant or a corporate gathering, today's audience has very low tolerance for fuzzy pictures, buffering, beach balls, bad sound that sounds like robotics or something, like a robot talking. And even on planes, right? I
Right.
mean, I can't stream on the plane. What are you good is this? 1998, and so I would imagine this is something that customers are demanding. Right? The
Certainly.
market's demanding.
Yeah, and to solve that problem that you just described, what historically happened is you would build a bespoke, almost air-gapped AV network to run all that traffic over, because you're very concerned that all my other traffic may disrupt it. And you'll get the buffering or you'll get the dropouts, which again, people have no tolerance for. If in a public setting, it can put you in a very embarrassing situation if you're trying to produce an
Yeah.
event. And our goal is that you should be able to run all of this traffic over one network, whether that be your standard corporate traffic or your AV traffic, and the network itself is smart enough and in an automated way can identify the AV traffic and prioritize it to ensure a very high quality of service, even if you have bursts of traffic coming from your sources. So we want to simplify the network design. We want to provide a very consistent and out of the box experience when you're deploying this, and allow those networks to converge, which ultimately saves customers time and money when they're deploying and operating this infrastructure.
You just described us here at Techstrong. We were talking before we got on that I'm in my Techstrong studio today, and we actually have 3 different sets where we
Right.
could be shooting concurrently, and then we're streaming, streaming up into the net, bringing stuff down. And that's exactly what we have a QoS, and by the way, we have 3 different bandwidth providers coming in here, right? All fiber, because we can't afford to be down. We need that kind of redundancy. And that's exactly our challenge, right? Having a QoS sort of router or switch, if you will, that brings in all 3 of these bandwidth providers, divvies up or prioritizes our traffic based on, our wishes, and normalizes all of this, right? And by the way, we need Wi-Fi for everyone sitting at their desk,
That's right.
right? Just good old Wi-Fi. And um, it's not easy, and it's not getting easier, because I think the lesson, and you've probably seen this in your years at RUCKUS, we're never going to use less bandwidth. We're never going
No.
to want less speed. We're never going to transmit less information. You know, I remember when I thought my 30 megabit hard drive was more than I'd ever need, right?
Right.
And
And
look where we are.
the mindset now, and we take it for granted to the extent now we perceive this as a utility, right? The
Yeah,
reliability is the same as the
that,
power and the water. It just always has to work. And by the way,
well, that's the
if you
expectation.
ask me to give up one of those, I'm going to give up the hot water before I give up the Wi-Fi.
Definitely a few of my engineers here qualify with that, I'm pretty sure. But yes, you're right. But it is. I mean, today's consumer, and I don't mean it as a consumer like C, I mean consumer of bandwidth, let's call it,
Right.
right? Whether they're in an enterprise or at home. Their demands and expectations are, you know, sky high. I wanted to work. It's like the old Mac ad, I just want it to work. I don't care what you're doing. I want it to work all the
And
time.
there's I think being in this industry and running this business, I have a deep appreciation for the complexity underneath all of that to make it work.
Yeah,
And we've got really incredible and talented engineers that work tirelessly to ensure that at the end of the day, the customer can take it for granted and they can perceive this as a utility, regardless of whether you're passively browsing over the Wi-Fi or you're transmitting your 8K video over a network. It's got to work under any conditions with that enterprise grade quality and reliability.
absolutely. Bart, I'm going to assume people could go to ruckusnetworks.com and look up more information about this new switch portfolio with the AV enhancements.
That's right. I think one of the things that maybe caught us a little bit by surprise when we were developing these advancements is not only were the capabilities in terms of the protocols themselves really important, but also the aesthetics of the solution, right? Oftentimes these are going into a home, and if you open a typical wiring closet in an office, you see wires coming out of the
Spaghetti.
front of these panels and patch panels. In a home, they don't want to see any of that, right? So we actually had to physically put the switch ports on the back, so you just see a nice, clean, flush panel. So a lot goes into engineering these, both mechanically and otherwise. And you can certainly find more details at ruckusnetworks.com.
Let us quick. One other area I wanted to hit on, Bart. I know we're running low on time, but you guys also recently announced a strategic relationship with Crestron, one of the biggest,
Yeah,
communication solutions providers in the world, and you joined this SDVOE alliance.
certainly.
Put them together for me so people know what we're talking about.
Yeah, I think in the realm of AV, home AV solutions, smart home solutions, building management solutions, Crestron really stands out among the leaders, and so ensuring that we are interoperable with our Pro AV solutions out of the box with Crestron was very important. And in partnering and joining the SDVOE Alliance, we have access to all of these protocols and the way to measure and test the fact that we are compliant and interoperable is really important there. So these two partnerships are ones that are core and fundamental to our success in this space, and we're really proud to be part of these organizations and their programs.
Fantastic. What is the SDVOE Alliance? What's SDVOE stand for people who are not familiar?
Video
You-
over something video over Ethernet.
yes,
At the end of the day, there are very unique sets of protocols that have been devised in order to transmit, a high definition video and audio over a traditional IP network. And so the SDVOE Alliance defines a standard by which you can do that. And if you adhere to that standard, you're going to be able to provide that very high quality of service, even for low latency or latency sensitive and jitter sensitive traffic like video and audio.
absolutely. I'll just close it with this. We recently in the homeowners association where I live recently went through a thing to adopt a new bandwidth provider. And a lot of this stuff came out, they came in to talk to us, and The idea is, sure, you might use 5G wireless today, and it works for you on your standard or HD definition, and you don't really do much. But with AI and everything that's coming down our pike, even in the home, and so many of us working from home, using video teleconferencing and stuff, you can't afford to be, running on, running on, a cable where you're getting 40 megs up tops, and maybe even a gig down, but 40 meg up tops. It's just not going to cut it in 3 years or 5 years.
Yeah.
You need a big boy, and I don't mean it in a bad way, but you need a pro solution that is going to enjoy all these new great things that we have available to us.
But simple to deploy and manage, and I think that's
if we're using
ultimately
it
our
home,
philosophy. Take all the complexity in the underlying solution, but make it very simple to adopt in a plug and play fashion. That really was our design approach with this latest Pro EV line of switches.
I love it. Bart, we got to run. We went way over time, but it was great catching up with you. Don't stay away
too,
so
Alan.
long. Come back and keep us posted.
We'll be back. Thanks so much for the time, Alan. We'll talk soon.
My pleasure. Bart Giordano, President, RUCKUS Networks here on Techstrong TV. We're going to take a break. We'll be back. Hey everyone, it's Alan Schimmel from Techstrong. Welcome to our next session in our dynamic series of conversations between select thought leaders at Microsoft, as well as some of the analysts from the Futurum Group. In this session, we have Tiffany Treacy, VP of Product Management for the Power Platform at Microsoft, and as well as analyst from Futurum Group, Keith Kirkpatrick. This session is titled Agentic Automation. In this session, Tiffany is going to lead us on a deep dive into the operational realities of agentic automation. It's a world where apps, agents, and chat are converging to reshape enterprise execution. We hope you'll discover how AI empowers everyone, with a special focus on those who need accessibility and disability support. You're going to learn how business users supervise autonomous agents that execute, escalate, assist, driving inclusive productivity. Expect insights into multi-agent orchestration, human-in-the-loop governance, and chat-led transformation across support and product activation. So another great session. Here's Tiffany and Keith.
Thanks, Alan. I'm Keith Kirkpatrick, Research Director with the Futurum Group, covering enterprise software and digital workflows. Today, we're going to be talking about agentic automation and how it is reshaping enterprise execution, where apps, agents, and chat functionalities are converging to assist across workflows, driving external engagement through the delivery of personalized, intelligent experiences and streamlining interactions.
And hello, my name is Tiffany Treacy, and I'm the VP of Product Management for the Power Platform Core, which covers our Power Apps, Power Automate, Power Pages, RPA, and process mining. I've been with Microsoft for 25 years in a variety of product roles, and looking forward to the conversation today.
As we're both aware, we really can't get away from a discussion about today's technology without talking about agentic AI. And I wanted to first start off by asking you about some of the ways in which agentic AI is changing the way customers are engaging with businesses on a day-to-day basis.
Yeah, so I think it's great if we first start with the fact that agentic AI is going to change the way we work, right? We're moving much more into these human-led, agent-operated environments. And some of the big changes that come with that are we're going to move much more from this very task-based focus to a more intent and goal-driven focus. And we're going to move from working like in a particular app to really working across apps. With that, we'll see this synergy of humans that are, driving what we're going to do. They're adding business intelligence. They're guiding. We're going to have agents that really do a lot of the execution work. We're going to have intelligent apps where these agents and humans can dock in to manage everything. And we're still going to have automations like we have today for very deterministic workflows. When we put all of that together, what we get from a customer experience is they're going to get much more personalized and contextually relevant experiences much faster and with a lot less effort on their part. And in fact, in many cases, we see that customers, organizations will be able to expand the audiences that they can actually serve with this technology. So like a simple example that might be, I'm on a flight. Turns out I'm going to miss my connecting flight. Today when I land, I might get a text message that I've missed my connecting flight. But you see very quickly, I'll land. The airlines has already rebooked me with an agent. They're going to let me know what my new flight is. And then if that doesn't work for me, they're going to give me a human to escalate. That's going to change in these kind of customer experiences.
Can you talk to me a little bit about how we're going to see all of this automation, intelligent automation, be managed?
So one of the powers of this agentic transformation is you begin to get intelligence on tap. So you have these different agents that you can leverage for different business functions. A level 1 agent, I think most of us have probably experienced in this point, and that is AI is maybe we're asking it questions or it's giving us a set of information. And then you have level 2 where the human is actually directing the agent to conduct some sort of task, and then the business rules dictate when the human will get involved, and it may be just giving the human information so they can make a better decision. And then level 3 is where you see these agents actually taking action aligned to the business rules and the human being in the loop aligned to whatever business rules you set. So what you'll find is that the goal of how we're thinking about agentic AI is we want humans to continue to work in the way they do today. We want them to have a personal assistant that transcends with them throughout their day, whether in their business data, their productivity data, whatever tasks they're doing. And then they will have intelligent apps that let them manage some of these autonomous agents. But those agents can dock into their personal assistant. They can dock into their agents. So we really want that humans continue to work the way they do today, that this AI will sort of collaborate seamlessly with them. And that's why you see that using both intelligent apps and kind of Copilot in this chat interface have their place depending on what the human's trying to accomplish. And so we want this all to kind of slot in more seamlessly versus thinking about it as like they have to change as much the way they work.
Right, that makes sense. But I guess one thing that I'm particularly curious about is as we move into this world where we have agents that work alongside of humans, and there are obviously going to be agents that work sort of autonomously, obviously still with a human in the loop to make sure that they don't go off the rails. How do you actually coordinate multiple AI agents across a platform to make sure that, the agents do what they're supposed to do when they're supposed to do it?
Yeah, it's an excellent question. It's very inherent in the platform we're building across both Copilot Studio and Power Platform, and of course some of the pieces in Azure. But it is very straightforward to design for a particular agent what its rules are, what it's allowed to do, what knowledge it has, what memory it has, what kind of guardrails it needs to follow. And what we see as customers are moving to these level 3 agents is they're really thinking through their business processes and chunking those up into reusable components. So maybe, for instance, you interact to gather information from an external company, and you do that for several business processes. You might build a dedicated agent that does that and gathers that information. That will have a set of business rules that you set for that agent. It will have a set of points where you escalate to a human or where the agent can actually take action. And then that agent may talk to another agent. Again, you define what that communication is and the business rules. So it's very configurable to what your business policies are, what your risk tolerance is, depending on the impact. The other piece is it's quite straightforward to evolve those business rules. So maybe, for instance, you start with an agent that makes recommendations on approving insurance claims or approving purchase orders. You might say that when you start, every single one of those has to be validated by a human. Then maybe you say, wow, that's going really well. If it's under such amount, $1,000, the agent can auto approve. If it's over that, the human still has to make that decision. And then you keep ratcheting that up as you build confidence in the agentic system you've created. And those things are very straightforward to configure and continuing to evolve.
Actually, how does Power Platform help to sort of manage that as you're talking about multi-agent orchestration across different modalities, whether we're talking about chats, applications, and back-end systems, because that seems like that's going to be a core sort of requirement as organizations, whether they're dealing with regulated industries or not.
Absolutely. So when you think about the Power Platform, one, we have a tremendous amount of line of business, large scale apps running on the platform today. And I think it's really important to note for those customers, we are going to bring AI to where they're working today and let them use AI to add even more value to the applications they have today. Then we're introducing new tools for building agents and some of these intelligent apps that will dock the agents in. All of that will still run on the Power Platform managed environments. So all of the governance that you're used to in the Power Platform will extend to this agentic transformation so that customers have confidence that they are running in a managed environment, that they have the ability to set the policies, to manage it, to audit it, to understand RAI, all of the different components they need. But that will be within the core platform that they have come to trust in managed environments.
Tiffany, you just mentioned something that's really interesting, and you've been talking about it throughout our conversation about the idea of human-in-the-loop governance. I'm curious, how do you actually embed that into agentic workflows without sort of slowing down automations or creating unnecessary bottlenecks?
So human-in-the-loop can be orchestrated at any milestone in the process that makes sense for that process or that business. This is one of the places that we think intelligent Power Apps is going to play a large role. So you can imagine that I might have, 1,000 automations or 1,000 agents that are running, and I have this intelligent app that lets me go through and quickly approve, guide, change, whatever needs to happen to ensure that the human is guiding but not slowing down the process. And I think this is one of the roles we see for intelligent apps as we go forward.
What about, the other thing I've heard about is the use of adaptive risk models and how that might help ensure that agents just remain compliant with any kind of regulatory or even business guidelines. Can you talk to me a little bit about that?
So for every agentic solution, the organization really needs to think through a concept we call evals. And those evals are what are letting you know that the quality, the functionality, the reliability is all within your guidelines. And so it depends on the agentic solution, but you're going to have metrics that tell you the functionality and the reliability. It's going to let you know the quality of the response. If it's an agent that's creating some sort of UX or interface, you're going to have metrics that let you test if that is high quality and functional. And then, of course, you're going to have evals around responsible AI. And so depending on the solution, one of the first things you want to do as you get started is define for the type of solution you have, what are the areas that will be key and what are the metrics and tests you want to use? And then there'll be multiple ways to ensure that those metrics are on track.
So we've heard a lot about agentic AI, but one of the things that I hear from talking with companies is that there's still a little bit of fuzziness or confusion around what sets agentic AI apart from sort of the chatbots or assistants that we become accustomed to dealing with in our everyday lives.
There's a number of things. One is that an agent, if you give it to them, has memory. So they can remember previous conversations with you. They can remember previous context. The second is that the agent can learn. You can continue to train it on knowledge, and it can continue to learn and be more and more helpful as it goes along. It also has not just the initial knowledge that you trained it on, but it has generative AI, which helps it to fill in the knowledge that you've given it. So you can think of it as all the power of the orchestration and the LLM or the large language model with your specific information on top to personalize it. All of those are things that chatbots could not do. Chatbots also cannot take action. So chatbot it was a great at the time, but it's really more of like a Q&A with very curated answers. When we get to LLM, it has all of these richer capabilities. And so it's not only quicker to get the information back to the human, but it also can do more of that on its own because of the context, the shared memory, the knowledge, and the fact it can take actions.
Well, one of the things I think that agentic AI is really sort of building on is that chat modality where you're able to use natural language to interact with it. Do you see that as being sort of, another sort of real selling point for using agentic AI? Because you are able to, anyone can interact with it. You don't need to program, you don't need to remember specific terms or anything like that.
Natural language interfaces are going to have a large role in agentic AI because as humans, that's an interface that we enjoy, and has a much lower barrier for people to participate in. So I think natural language and being able to, type what you want an app to do or what you want an agent to do for you and be able to go create that will absolutely have a large role in that. Again, I think it will depend on the business solution. We also know that humans are more comfortable in sort of like a personal assistant, like a co-pilot realm, talking back and forth because that's how they interact with their other coworkers. And so we really want, as much as possible, to have the humans still work in the way that they're accustomed to working. So they might, ping a coworker to ask a question. Now they might ping their personal assistant to ask that question. There will be places where they'll actually go into an intelligent app because that's the best interface for them. And then they may continue to ask their personal assistant questions about that app. So they will be much quicker to learn about that app and what they're doing. But then natural language interface is definitely going to play a key role because of the way it lowers the barrier and allows humans to continue to interact with the technology in a way that they're most comfortable.
So it sounds like what you're describing is sort of an agent first or assistant first approach to interacting with systems. Is that kind of what we're moving toward?
I would kind of flip it around. I think it's a human first, a human led. I think that human is going to have a personal assistant like Copilot that transcends their day with them, understands their productivity context, their business context, how they like to communicate, how they don't like to communicate. It's going to be more kind of, I'll call it, connected with the human and their personality. And then I think there's going to be a set of intelligent apps and agents that dock into those places. Agents may dock into your apps. Agents may dock into your personal assistant, depending on what they do. All that together will build kind of the new tapestry of how we work and how we move forward. But I think it's the human at the center with these technologies, helping to make them more productive and giving them more time to think strategically, to be creative, and to think about what they can do next. We know from all kinds of studies that 80% of people in organizations say they don't have enough time to do what they want to do, to think about the things they want to think. So we're thinking about how we empower that human and how they now have more time for those strategic, creative things. And then this technology is really helping them along the way.
Tiffany, one thing you mentioned is that AI should be for everyone. And I'm curious if you could talk a little bit about how agentic automation can help ensure that people with disabilities aren't just included, but actively empowered as they're working and using enterprise workflows.
Yeah, this is an area I feel extremely passionate about what we've seen so far with particularly Copilot and some of the automations that have been done in Teams and some other places. So, there's lots of different situations that people with disabilities face. You may have someone who has hearing loss, and now with the transcript on a meeting, they can fill in where something wasn't quite clear to them. You may have someone who has ADHD who focusing on the meeting and the notes, they feel like they miss out on both fronts. I think that's a human experience across the board. Now with meeting notes and the transcription, like you can stay 100% focused on the conversation, the meeting, and know the rest of that is going to be there for you. You could flip this over to other environments like schools or education, where the concept of meeting notes can help students take notes in lectures and they can have it all there so they're focused on their learning in the moment. I mean, a lot of these agentic AI pieces are going to help humans be fully present in the moment and know all this other stuff is there for them to use later, but they're not having to multitask in the moment. And the numbers are showing people see the real impact to that. They feel like the quality of their work is better. They feel like they are more included. They feel like they have better performance. And they feel like the meaning of their work has actually gone up. We're just seeing the beginning of all the impact that this is going to have for us.
Tiffany, can you give me an example where agentic AI has provided an outsized impact above and beyond what you either might have expected or what we could have previously done?
Yes, we see many times that the spark for starting with AI is around efficiency or productivity. But what we're hearing from customers is they're seeing a number of other vectors of impact. Accessibility and inclusion has been a really strong one, which I'll talk about. Being able to upskill and learn has been another one that's come up quite strongly. In fact, EY, Ernst & Young, recently did a study where they interviewed over 300 people who had been using Microsoft Copilot, asking them, how did it impact their work? All of these 300 people identified as having a disability. And over 75% of them said they felt like Copilot had made them more productive at work. They kind of laid that along three lines. One was removing barriers. 88% said they were doing better communications by using Copilot than they had in the past. They also talked about feeling more included and feeling like the quality of their work had gone up. That was over 85%. And they also talked about feeling like they were getting more meaning out of their work because of their productivity and the quality. So that is just a tremendous additional benefit that we're seeing from AI, where organizations are able to ensure that every team member is bringing their best selves to work and doing the best role that they can. And I think we will just see more and more of this as we move forward, because as Copilot and some of the other AI continues to learn even more and more and becomes more personalized, it can even help in other ways that will be very valuable for people.
So, Tiffany, I was wondering if you could share some examples about how agentic technology is being designed with accessibility in mind.
Yeah, so as you know, Microsoft's had a long history of thinking about accessibility features in our products, whether that's been sort of in Xbox and assistive controllers or Office and the many accessibility features we provide there. That same sort of mission is moving into agentic AI. So we can think about what are the new accessibility features that maybe in the past weren't as feasible that now we can bring to the forefront. Some of them are already out. You think about Teams meetings, Teams transcripts. You think about things like Copilot being able to ask questions across all of your graph data. As we move forward, we see even new opportunities. For example, the Teams team is thinking about how today in a Teams transcript, you have whatever has been said verbally. You know, it might be another language, might be in English, might be in multiple languages, but it's what was spoken. In the future, what they want to do is include what was signed in the meeting into the transcript. So everybody has a complete transcript, whether that was spoken or whether that was signed. And that's just one example of the many type of agentic AI features that we feel like is now feasible that we're exploring.
So I was wondering if you could tell me about how agentic automation has really streamlined very personal or sensitive processes and procedures.
One of the areas that would be a great example of this might be human onboarding. So we each come to a new role or a new set of work with various backgrounds, with strengths and places, things we know nothing about. And agentic AI can really personalize helping that human on board in a way that they feel completely comfortable. They can ask many questions. They can get access to many resources. They can get recommendations and guidance that will help them learn at a much quicker pace, but not something whereas in the past they would have had to share very broadly with their new team that they didn't understand a concept or they didn't have this experience, or maybe it's very difficult in a large conference room to hear the voices. And so agentic AI has the opportunity to really help speed up that onboarding, personalize that onboarding, and do it in a way that is really taking the human into account and helping them do that in the best way possible, in a way that's sensitive to things and very positive and productive.
Well, thank you very much, Tiffany, for a great conversation and real insight into the world of agentic technology.
Thank you, Keith. I really enjoyed our conversation today. It's always fun to talk about the transformation that's ahead of us and how agentic AI is going to help all of us move forward.
Today, we heard a lot about agents, and I think some of the things that really resonated with me was the fact that ultimately, to have success, you need to start with humans, looking at processes and goals, and then bring in the technology. Now, of course, there's a need for platforms that can really provide an orchestrated agent experience across intelligent apps, agents, and of course, all of the workflows that are integral to really driving real business benefits. And ultimately, the other thing that really sort of resonated for me is the ability of agentic technology to improve the experience of people who might have disabilities, and to do it in a way that really takes into account how they're feeling and not really kind of separating them from the rest of the employee base or other customers, but to do it in a way that's empathetic and, again, can really drive outcomes.
Hello and welcome to the latest edition of the Techstrong Insight series. I'm your host, Mike Bizarre. Today we're with Jonathan Walls, the CEO for Runloop.ai, and we're having a little chat about, well, AI agent safety. They're starting to show up everywhere, but we're also starting to become aware of, well, just how powerful these things might really be, and we don't know exactly what they're doing and who might be using them when we're not looking. Jonathan, welcome to the show.
Yeah, thanks so much for having me, Mike. It's great to be here.
I can't help but wonder if maybe we're a little bit over our skis when it comes to AI agents. I think people are deploying them and they're seeing new products all the time, but we're also starting to see a lot more, at least proof of concepts and some examples of how these AI agents can be compromised. So did we not think through all the security implications of all of this? But what's your assessment of where are we?
Yeah, okay, that's a pretty broad question. I would say there's a couple things to click into there. One would be just kind of around how people are using agents and then how people are deploying agents at scale. I think one kind of curious thing or something that I find a little puzzling or interesting is how many people are trusting these very powerful agents with really pretty broad access to their laptops. So your laptop, if for me, for the sake of argument, if I happen to be doing a infrastructure as code push to AWS, I'm signed into AWS. I'm credentialed for network access to our production environment. If I'm running Claude Code as, user wall on the very same laptop, these guys have done great things. They put in good guardrails, but that Claude instance running as me has access to a lot of the capabilities I have access to. So kind of one topic would be, how safe is it to run on your laptop? I think that is, kind of an area of open discussion. I think then the, kind of another dimension of this would be once you've deployed these agents to the cloud, right, where they can presumably run at scale, how do you provide them access to the correct things, but also prevent them from doing damaging things or expatriating data to unintended sources?
So is it just now a matter of time before there's going to be a series of catastrophic events involving AI agents and there'll be some backlash, or can we get in front of this a little bit and maybe put something in here to prevent that from happening?
I would hope we can get in front of this. I think you've seen there have been a couple little flare-ups. I think last summer there was an engineer on social media kind of bemoaning the fact that they accidentally just deleted their production database. You see the AI agent. So I think there are some isolated incidents. I would credit a lot of the agent builders to working really hard in terms of adding sandboxing. So like the Claude folks, Codex folks, Gemini folks, they do their very best to sandbox the agents that run on your laptop. So, there are certainly preventative steps people are taking on your laptop. I think when you start to deploy to the cloud, people are starting to take steps, but there's a lot of work left to do. We think being very cautious about how you isolate the agent. So it's in a sandbox that it can't escape. And even if it does escape that sandbox, it can't do kind of migratory attacks against its neighbors. We think that's necessary, particularly in the case where someone might maliciously use the agent, right? You can do a lot of things to try to make the agent not do bad stuff, but clever actors can kind of override that. I think we saw this with that kind of Chinese state-sponsored attack that leveraged Claude, that split up kind of their attack into lots of innocently seeming smaller tasks to try to not be noticed. So there's a bunch of stuff that people are trying to do on your laptop. When you actually deploy to the cloud, you have a lot more control, right? The deployment environment is exactly how you set it up to be, right? You can control what context is on there. if people are doing a good job in terms of isolating these agents inside of containers and micro VMs, you can be pretty confident that they can't do kind of transitive attacks on their neighbors. In robust cloud environments, as you well know, give you the opportunity to have like very strict like network isolation and network boundaries as well.
Do we have the tools and technologies required to achieve that goal, or do we need to maybe invent something that doesn't exist yet? But is it more a question of let's implement stuff that we already have that we haven't broadly adopted yet to deal with this, or do we need a different approach altogether?
That's a really good question. I think it's kind of a blend of both answers. I would say that for the most part, we have a lot of the primitives we need, at least at the kind of traditional compute layer. We have a lot of the primitives that we need. It's really a matter of composing them in an opinionated way so that it's easy and ergonomic to kind of isolate these agents and be more confident in what it is they're able to do or not do. To give an example, right? Like micro VMs are super powerful. They're used widely. They're great. Container technology exists. It's great. There's wonderful network technologies like we use Cilium ourselves that let you do really fine-grained networking controls. It is great. It's just the problem then becomes how do you compose, a lot of different layers of the stack in a fashion that is ergonomic and easy to use. So that people who are developing and then deploying these agents can reap the rewards of these kind of compelling technologies.
Are security people conscious of all of this, or are they just kind of waiting and watching? And I ask the question because I feel like nobody wants to be the proverbial party pooper, right? Everybody's having a great time with AI and agents, but nobody wants to be the one standing in the middle of the room going, be careful out there. It could be doom and gloom. So are they just kind of waiting for the crisis to emerge before they kind of step up a little bit more aggressively than they have to date?
Yeah, I would say there are like a lot of different surface areas to contemplate here, right? Like if you look at the laundry list of things I just gave you, right? Like network isolations, micro VMs, like these are very like nuts and bolts, like kind of physical infrastructure layer considerations. These are the kinds of things that I think people are really dialing into right now. Like a lot of our customers, our company Runloop AI supports these things, but a lot of it is customer driven so that, people are aware. I think that is a surface area that's like a little easier to reason about. I think some of the kind of AI level things and the prompt injection stuff is a little more open-ended and is a little bit harder to reason about. I think when you throw, more extensible patterns in the mix, like MCP, it kind of introduces another even broader surface area. So I guess I would say that I do think that across the board, there are different security experts worried about different layers of the stack and doing different things. I don't know that there's any holistic solution in place just yet, though.
So what's your best advice to folks about how to approach this? Because I think that there is a lot of nuanced issues, and at the same time, there's a lot of technology that you need to master and they may not be familiar with. So is there a savvy way of thinking about all this and maybe having this conversation with the leadership of the company?
Yeah, it's kind of like, it sounds a little boring, but it's the kind of the classical thing, right? Like you start with a position of like, what is technically the bare minimum of necessities? How do you set up like a least privilege environment and then gradually add things as you really need them, right? And, this is why we think like a micro VM and good network isolations are really the right building blocks. From there, you also need to be very careful about the content that you're making available and the tools you're making available, to any agent. And, one layer above, you need to make sure that the agent never has direct access to any sort of credentials that could be, made rendered public via prompt injection. I think it's kind of the same old story for security, right? Like you have to have an approach where you start from good principles, least privilege access, and you kind of layer things on as minimally as possible for the thing to actually then function.
Do you think auditors will soon figure this out and start asking more difficult questions of people? And will there be more compliance violations because the auditors will be like, well, I don't care if it was AI, the rule is the rule?
Yeah, this is going to be an interesting one. I think the security engineers, kind of, at least in my experience, tend to kind of front run the compliance and audit type people. So hopefully we've raced ahead. So by the time they start asking these questions, we have good answers. Right now, I'd say from an audit perspective, we're kind of in the kind of phase of like, hey, log everything, and then we can see whose fault or what went wrong when it broke, as opposed to being a little more sophisticated. But I think that will come.
Do you think there will be more regulations about the usage of AI agents, or does lawmakers even understand how these things work yet? And maybe it's a little bit beyond their core capability at the moment, but at some point, will somebody look at all this stuff and start making some new rules?
Oh, I think, lawmakers love to make laws. I'm sure they'd love to. Yeah, I guess I would say it's an industry that is in many ways like kind of our maybe this is kind of our challenge, is this kind of nascent technology kind of, grows to become mainstream and widely adopted technology, is to see if we can sufficiently conform to like the existing regulatory standards with like modest extensions versus having like sweeping new, laws and compliance burdens put in place. I would certainly hope so. I would certainly hope we can arrive at that outcome where there's, for every, whether it be SOC 2 or, GDPR or any of these kind of standards, I would hope that there's just modest AI extensions to them, as opposed to entirely new regulatory regimes that are really wide reaching. I hope.
So what is that one thing you see people doing today that just makes you shake your head a little bit and go, folks, we need to be a little bit smarter about this, because if we're not, things might go south?
I think this is getting buttoned up rapidly now, like kind of in response, I think, to the state-sponsored attack that Anthropic revealed last fall. But I do think running stuff on your laptop, kind of as your user, launching an agent that has access to lots of files and lots of state on your system and lots of credentials, I think that was a little bit wild. I think now the major labs and Claude is doing a great job of this, or really Gemini as well, Codex, all of them are really, really trying to put good sandboxing in place for your local laptop. But, I think ultimately, at least in my opinion, the right answer is to not be running too many of these things directly on your laptop, for them to have dedicated sandbox cloud environments, and ultimately, hey, like, I don't want just one or two agents running. I might want lots of them. So, the scale of the cloud is appealing in that regard anyway. So that might be something that, I guess in the past that made me a little worried, but people are working pretty hard on that as well.
All right, folks. Well, you heard it here. Hey, we got to figure out how to maybe limit the scope of the potential breach, which fundamentally just comes down to, we got to run more of these things in isolation so that if something does go wrong, it doesn't go wrong everywhere. Hey, Jonathan, thanks for being on the show.
Thanks so much. Cheers.
All right. And thank you all for watching the latest episode of the Techstrong.ai Leadership Series. You can find this episode and others on our website. We invite you to check them all out. Until then, we'll see you next time.
Once more unto the breach, dear security researchers. Welcome to Security Boulevard, the cybersecurity podcast from the Futurum Group. Each episode explores a variety of topics within cybersecurity and the technologies that drive it. You can find us on securityboulevard.com, the Security Boulevard YouTube channel, Techstrong TV, and all of your favorite podcast platforms. Let's meet today's guest before we jump in, starting with our old friend, Mr. Alan Schimmel. Alan, it's good to see you.
Good to see you, Tom. How are you, man?
I'm good. It's getting kind of interesting trying to keep up with all the security news out there, but I think we've got a fun topic for today.
Yes, it's that old. I don't know if it's an Irish proverb, an old ancient Chinese saying, or something in Hebrew. But may you live in interesting times. These are certainly interesting times. Or Fernando's going to tell me it was actually Brazilian, but
No, 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 no. It's not Brazilian. Brazilians right now, as we're recording this, Brazilians are busy wrapping up Carnival. So yeah, they're not thinking
that's
about
true.
Proverbs.
They're probably still asleep, but luckily someone woke up to join us, and that voice is Fernando Montenegro. Fernando, it's good to see you again.
Oh, it's lovely to be here. Thank you so much.
All right. And of
Yeah.
course, I'm Tom Hollingsworth. I'm the event lead for all things related to security here at Tech Field Day. Let's jump into today's episode. I'll give you a hint. We're going to be talking about AI, but we've got a couple of topics that we want to discuss that kind of meld together. The first one is the fact that Anthropic has started kind of letting Claude off the leash a little bit. It has done some vulnerability scanning and managed to turn up over 600 vulnerabilities across various open source projects. And that has some security researchers asking some very interesting questions about the capabilities of AI systems to be able to do threat modeling, threat hunting. One of them in particular that I thought was kind of interesting, I believe it was in Ghostscript, was a vulnerability that no one had been able to find for years. And the way that the system actually found that vulnerability was novel. In short, it said, well, this was a problem that they patched years ago, but did they manage to patch every instance of that across every software release? And it actually found out that they hadn't. And so it used that as a potential avenue for exploit. So I kind of want to jump out here by saying to the group, is the power of AI in this case the ability to iterate across every version of every product to find something that we might have missed along the way?
Let me jump in just for a second. I think that one of the things that we have to, let's go back, forget AI for a second, right? Normally, how would we find vulnerabilities, right? You can read the source code, you can brute force something, like we've done fuzzing forever, right?
Mm-hmm.
What I find fascinating about this is that this is it what AI can do, or what at a very expensive cost. We can get into the cost later, but what AI seems to be able to do is to, quote unquote, reason through these different stages of analyzing a piece of code. And what I personally find fascinating is not so much the number of vulnerabilities it found, but the fact that it went through these methods, that we are codifying these methods along the way. And of course, if we're codifying them now, it behooves us to think that we'll see more efficient finding in the future. Like, where else can this be applied to? So that's the thing I found really interesting about this.
I think you got to look at this with a little historical context. And Tom, you touched on it there. Before we had AI and before we had Claude Opus, and let's be clear, this isn't just Claude, it's Claude Opus.
Yes,
It's
4.6.
released, I think Opus 4.6. But before we had these things, how did we find vulnerabilities? How did we find bugs? Well, hopefully we did a lot of testing pre-release and found bugs and fixed them before. But the fact of the matter is most bugs in production systems were found two ways. The really bad way is the bad guys found it and they exploited it and made an attack. And my goodness, when the stuff hit the fan, we said, how did this happen? And we find out, and then we patched it. That's the worst case scenario, right? A better case scenario was good guys found it. Somehow or another, we found it. And it was very hit or miss for many years, especially when I first got into security. With the advent of bug bounties, right? And I forget her name now. She worked, Katie Masouris.
Yes.
Started with the bug
Crazy.
bounties and everything else. And then probably the rise of security researchers who were just out here looking for bugs, and they got paid a couple dollars when they got paid a lot of money if it was a big bug. But with those security researchers came the rise of fuzzing, right? I remember when fuzzing was a new thing. But with fuzzing, you could go to any open source project or any kind of website or whatever and hit it with a fuzzing scanner that would, this is before we had AI, as I said, but it would try a lot of different variations and see if it found anything. It was like, putting a blind person in a round room and saying, go find the corner. It really hit or miss. What we have here with AI, it doesn't fuzz like a fuzzing scanner does, but it takes fuzzing to the nth degree. It could look at the code and run the permutations, if you will, to find those corner cases, to find those, situations where something could be exploited. And that, this is an article, it's up on DevOps.com, I wrote about this. Is Claude Opus the greatest security researcher of all time? It's the fastest. It found 600 bugs in open source projects in a few days. That's like a year's worth of research in a few days. So fundamentally, that changes the game, right? Our friend Fernando, our friend Gotti Everett, and a young lady from Google, and I think it's Heather, but I may have her name wrong, but it's in my article. They called this to the day 6 months ago. They said, we're going to have an apocalypse, a vulnerability apocalypse, where AI's ability to find new vulnerabilities will outstrip our ability to keep up with it. They said, give it 6 months. And almost 6 months to the day later, this came out.
So I don't want to disagree with you, Alan. I finally get to say that. I don't want to disagree with you, but I have some problems with this. So here's my first problem. It discovered 600 vulnerabilities, right? Where's the CVSS details for those? They didn't publish them. In fact, of the 600 that they published, they only talked about 3 projects, which already kind of makes me wonder what's going on. Because I didn't realize this until I did some research, but did you know that Claude Opus 4.5 had a little problem with the malloc call in programming? It would flag malloc as a potential vulnerability every time because malloc can be overflowed. Even though the programmers would immediately point out, you realize that we wrapped it in an error handler so that if it ever did overflow, it would immediately dump out and it wouldn't actually create a vulnerability. But just like an overeager intern that's 3 days out of college, it would flag every instance of malloc that it found, not realizing that there's probably no better way to do that. Because all you got to do is go out to the Linux kernel mailing list and wait for 3 months until someone suggests rewriting the Linux kernel in C++. Because everybody does it. It's a truism. Because everybody thinks that there's a better way to do it, even though the guy who's been writing it for the better part of 30 years knows there's no better way to do it. Just grab the comments for some of the drivers that have been submitted. Some of them, I love the comments of like, don't ever effing touch this because nobody knows how it works, but it works. That's the perfect thing for AI to go, no, I can rewrite that. I think it's also telling that you brought up the bug bounty program. Because one of the problems that we're seeing with AI is that AI tools are causing bug bounty programs to get shut down. All you got to do is go look at the curl utility. They had to shut down their bug bounty, like absolutely crater it, because so many people were analyzing the curl programming database with AI tools, and they were catching all of the errors, and I use the quotey fingers there on purpose, and then they were submitting them hoping they were going to get $100 or $1,000. And finally, the maintainer said, no more, because I can tell when it's AI. I can tell that you aren't actually doing any of the research around why that was written the way that it was, and you're just hoping for a quick cash in. It's the same problem that we've seen 100 times. When there's a new tool out there that people think will lessen their workload, their very first solution to using it is get rich quick. Because remember script kiddies? Back when they had nuclear weapons and push button capabilities? What did they do with them? They used them to start extorting companies. They used them to start trying to break into places where the security was subpar until we improved our security. I think we're in an era of AI kiddies where they have access to these massive tools and they can pay $20 a month just like the rest of us, and then they can go out and try to basically recoup that cost by doing all these things. And I think what's ultimately going to end up happening is either the programmers are going to have to get better, or they're going to have to put some very strict rules in place. We will not accept submissions from these tools. You need to provide like documentation or exploitability. Otherwise, we're done.
So, I'm conflating a bunch of different things here, and I'm sort of sitting in between in the context that I see different problems at scale here, different things playing out, right? I very much agree that yes, we should see more about those 600 vulnerabilities for sure. The other thing to keep in mind is that from what I've seen, that exercise costed $20,000. Right? It's not as if, hey, you're going to pick up a Claude subscription tomorrow and then start vulnerability finding your way across things, right? So there is a cost to these things, which of course, for a large criminal enterprise or a mid-sized criminal enterprise, and increasingly a small-sized criminal enterprise, right, is not out of the realm of possibility, right? Which ties us back to look at all the open capacity that's available right now with OpenClaw instances that are available at like 19,000, 20,000 or whatever, right? But sorry, I digress. There is absolutely what I found fascinating about the Opus thing is that it's how it navigated the problem. I think that the navigation of the problem was phenomenal, right? The other thing is that about the bug bounty programs, right? And I'm thinking here about the fact that, like, when we talk about AI security, we always talk about AI for security, security for AI. And one use case we rarely talk about is security from AI. What happens when your adversaries start using AI? And I think about this overflow in security bug bounties as kind of that problem, right? It's kind of like fraudsters trying to overload a call center, right? But I think that the approach here is to curate more. Like, of course, it becomes a more expensive to run a bug bounty program, right? But I think those can still be saved, right? Because have enough curation so that you can have like some automated triage early on, and then at some point, and the bug bounty companies have done this. I mean, HackerOne and BugCrowd and some of the others, right? Have invite-only programs. Hey, you can only submit. We'll only accept you if you are an invited. Like it's not as democratic as, hey, open up to the entire world, but it's an option, right? But anyway, I think that the broader point here is that there's tremendous value to what's being done. We're just trying to adapt to it. That's the.
So let me weigh in here. Tom, bless your heart. Listen,
He got all Southern on me there.
yeah, learn about fair play. But are you trying to make the argument that all of a sudden AI has created a situation where we have more vulnerabilities that aren't necessarily reachable, exploitable, or workable, or what you're really saying is meaningful, and this is just clogging up the pipes of poor vulnerability remediators' workloads? Is that the hill you want to die on? Because that's a hill that I've been watching the battle on for about 30 years. Nothing's changed. AI, don't blame AI for that. This is something that's been going on a long time. You got your telephone book, and for those of you who remember what a telephone book looked like, a telephone book full of vulnerabilities every time you use the scanner. And it was job security, right? It was like painting the Verrazano Bridge back home in New York. They start right after New Year's on one end. They finish right on the other end, right around Christmas. They take that week off and then start again on the other end for the new year. That's what vulnerability remediation's been like for as long as I've been in security. It's not new.
No, you're right. Vulnerability discovery is not new because we've been looking for these things for years. Any good programmer will do that. What's happened is that the speed that we can find them has drastically increased. And it goes back to things like
problem.
Yeah, like encryption keys, right? It used to be that cracking any kind of password or something like that would take orders of magnitude more time. But we have gotten to the point now, because of the massive amount of compute power that we have, with the ability to pre-calculate rainbow tables, that effectively any numeric password is instantly broken. Even lowercase passwords with a mix of numbers and letters probably takes about 3 days, whereas it used to take like 3 weeks at the best case. So the problem is we now have to adapt faster. AI has shrunk the window for us to find these things and remediate them.
Yes, it has.
May I bring into the conversation? I was looking for an economics term. Right? May I bring into the conversation the concept of the Red Queen hypothesis? Right. It's actually not. It's actually not as much economics as it is evolutionary biology, right? But it's how much you have to keep running, right, just to stay in place, right? And I think that what was notable to me on and Alan, I agree with you wholeheartedly. Vulnerability has been around forever. What is changing is that, oh, look, this thing needs to be fixed, not in 285 days. This thing needs to be fixed in a week at best, if not soon.
That's prioritization, though.
Yeah.
Right?
Yeah.
You can't fix all 600 in a week. You got to pick your battles. But let me also, Tom, to a couple of the other points you made and Fernando made. Why don't we have the list of CVEs and the whole list of 500 or 600 vulnerabilities? Because until patches exist for them and we're ready to patch them, it's called responsible disclosure. If the Anthropic people put that list out before there were patches out there, I call for them to be hung from the nearest tree. You don't do that. You can't do that. You can't do that. But
agreed.
That's first of all. Second of all, though, here's the real politics of this. Guys, if Anthropic or the good guy, quote unquote, good guy security researchers aren't using these tools to find these vulnerabilities, you know who is? Of course, the bad guys. And they're going to find them and they're going to pick the ones that matter, right? They're well organized. They've got great resources and this is available to them too. So there's a bit of a race here, right? And it's not a new race. It's just as you both have said, AI has upped the stakes. And that's what Gotti and the woman from Google.
You're thinking about Heather Adkins. She's a VP. She's amazing. She's one of the powers behind Google Chrome.
Yes,
right?
Yes.
Safe browsing. And
that's
she's
what
awesome.
they're saying. That's what the race is. Not that all these vulnerabilities exist. I think we all suspected that they are out there. But how the heck do we keep up with this? And that brings me to the next article I wrote. Son of Moltbot or OpenClaw versus Opus. It takes AI to beat AI, my friends. Right? And I think of all, OpenClaw could be a platform's T cells, a platform's immune system waiting in our bone marrow, if you will, of our platforms to take their marching orders to go out and remediate these, assuming we have remediations, to go out and remediate all these vulnerabilities that these AIs are finding, whether they're found by white hat, black hat, gray hat, no hats, right? We need something that scales. And I think AI, you're going to need AI is the bottom line here.
And absolutely. And I think we've seen some of this happening. I would argue that, by the way, I love the fun of multiple, that was so much fun. The thing I would mention though, that is that what I think organizations and practitioners should be on the lookout for is not just on the capabilities, right? It's not just, do we release a swarm of agents to fix vulnerabilities, right? It is our operating environment, are our development practices, are our software pipelines, is our change management process capable and ready for this type of autonomic operation. I remember that I go back years. I remember having this was the earlier days of cloud, speaking with the cloud architect for a very large financial institution. And the guy was nearly in tears, right? Because he was telling me, look, this was the time of how quickly can you deploy to prod? We can roll things out to prod within an hour, right? And it's amazing and it's wonderful. But CAB, Change Advisory Board, still only meets twice a month, and every change has to be approved, right? It was that experience stuck with me forever, right? It's like, can the way that we are running things match what the technology environment looks like? So my push to people is, okay, great. You can deploy all the agentic technology you want, but if you can't let the technology actually do its thing, is it really helpful?
So here's a lesson I learned very early on in my cybersecurity career. Mitchell Ashley and I were two of the three co-founders of a company called Still Secure. We had intrusion prevention, vulnerability management, network access control. At the time, intrusion detection was the standard, right? It detected a potential intrusion and alerted you. At the time, vulnerability scanning once a year was a wish. That's what you would hope. Many organizations did it. We came up with automations to automatically block the most obvious intrusions, to automatically remediate, put in a workflow and remediate vulnerabilities. Failed miserably. You know why? People were afraid to automate remediation. Fernando, much like your discussion, I probably had a discussion 5 or 10 years before yours because cloud wasn't around yet. But it was with one of the global CIOs for Citi. Back then it was called Citibank. Yeah, it was still Citibank. Now, of course, it's just Citi. How long does it take you to do your Microsoft Patch Tuesdays? To get your Patch Tuesdays done? 90 days. Now remember, Patch Tuesday came out once a month. They were 3 months behind, and some of those patches were needed, right? Critical. Why, Peter? Why 90 days? Because we have to test it across our entire network before we get approval, make sure it doesn't break anything, because we'd rather live with the vulnerability than break something else. Very similar to your cloud story. Now, I think the world has changed. I think we're more accepting of remediation. When I speak to the vulnerability vendors today, Fernando, like Qual, and I'm sure you speak to them too, Qualys, Rapid7, whatever, I forgot who owns EI now, but the company behind EI Scanner, the AppSec scanners, they're all building automated remediation in. I don't know, Qualys has this concept of ROC, Risk Operations Center.
Yep.
Where you make, a weighted decision on should I automate the remediation or maybe wait for a cap. But I think the world is changing. We are becoming more forgiving or open to automated remediation. We have to. When you've got this thing finding 600 vulnerabilities, even if only a quarter of them are serious, we can't wait 90 days or even 30 days.
And I think that is where we work. We should be helping people be more nuanced about their environments, right? There are environments where, yes, we should wait 90 days for a patch because we want to make sure it doesn't break. But here's the big thing. That environment has to have compensating controls to account for the fact that they may be, right? And that nuance of how far do you, how much do you add in terms of compensating controls is a risk-based decision, right? And requires a deeper understanding of the threat environment and the operating environment of what does your organization actually do, how does it do it, and so on, right? Which, to bring this back to Claude Opus, I find it fascinating that it accelerated it. In my view, like in this calculus, I see Claude Opus changing the threat environment. It basically said, look, right, for any kind of software that you're running, assume that someone can find vulnerabilities that much faster. If that is true, however they find it, what changes in how we proceed? Oh, you know what? Perhaps we segment our network. These machines here or these systems here we put on different controls than these ones, and so on. Right? It's the Red Queen hypothesis. Sorry, it's like you're changing your running just to stay in place.
So I would posit that the reason why it's taking 90 days in Alan's specific case, but more importantly, the reason why it takes so long to roll out patches is risk. We know that, but my posit there is you can't fire an agent or a script. Now you're probably thinking to yourself, yes, you can disable it or whatever. Yes, but you can't make it feel shame. And that's what people want when they point at somebody to say, you shouldn't have done this. They don't want to improve the behavior. I mean, yes, they don't want it to happen. They want that person to feel shame for having done it. They want to slow down the way that things are done because risk does not like speed. That's always been a problem. But
who's they in this equation?
In this case, it's the stakeholders in finance, in business continuity, the people who stand to lose money for any downtime, the people whose job is resource allocation. And they don't like doing things twice. They don't like unknowns because a vulnerability is a known problem. A patch that fails is an unknown problem because we don't know how to fix the patch. And Microsoft has actually had a problem with that as of late. The last couple of rounds of their big Windows 11 updates have had to roll a few things back because, oops, that interaction didn't work the way we wanted it to. And in fact, I found about one last night that's causing problems because the patch for the patch is causing problems. And so it's like you're 3 patches behind where you should be because every time you try to apply them, it breaks something new. So let me bring up this idea because I was thinking about this while you guys were discussing about what happens when we just kind of open it up and say, okay, we trust the systems enough to solve these problems. What happens when the attackers know that? So if you guys remember Star Trek The Next Generation, when they captured Hugh, the Borg, they had a plan. They were going to implant basically an unsolvable problem into Hugh and send it back to the collective and cause the collective to crash. What happens when I know that AI agents are the ones that are scanning for vulnerabilities and I start doing things to mess with them, to hide my real payloads? Remember the infinitely expanding zip file problem? Where you had like a 38 deep nested zip file that would constantly unpack itself until it overwrote your hard drive? Like, what if I leave one of those for an AI agent to find? Or what if I code everything in poetry so that it evades the detectors? Like,
now that's another Star Trek one right there. Remember there was a species who spoke like in parables and poetry, and
Darmok and Jalad at Tanagra.
Exactly.
But that's the thing, right? Is once I start crafting my evasion techniques to evade the scanners, who catches it after that? Because if I've turned my scanning over to the system, who goes back to look at the logs at this point and go, wait a minute, Shaka when the walls fell, that doesn't sound like something one of my people would write unless it was Billy, the Star Trek nerd over there in the dev system. But like, that's the deal. The attackers will always modify their systems to evade the protections that we got. It's one of the problems we face in the physical world, right? As soon as we started scanning everything for explosives, what did they do? They parked the explosives outside of the building. And now that's why you have bollards and you can't park within 150 feet of a federal building now.
So, but I think here's the weak link in that chain, Tom. Are the powers that be, the people who own and operate the code, are they going to purposely try to evade AI scanning, vulnerability scanning? I can understand if the AI scanners are being for the bad guys, right? That might be a way to kind of camouflage or what have you. But, for as long as I've been in security, and Fernanda, you've heard this term, Tom, you've heard this term, this concept of self-healing systems,
Mhm.
right? I think it was originally Cisco that came up with that, actually. But,
Mhm.
self-healing systems where why can't a platform, the same way the platform today in software supply chain security is applying DAST and SAST and SCA scans, why can't the platform do an Opus scan and find things as well? And and you know what? Keep it in the family. Keep it behind the curtain before it gets out in the public and the so-called hacker's eye view from outside. Why can't we build this into our platforms and into our process?
Well, part of it is that it costs too much. We go back to economics, right? The fundamental problem we have in this industry is that it's externalized risk, right? We are navigating the scenario of who's paying for this, right? At the end of the day, it's the end user organization that is that's paying an FTE to patch. It's an end user organization that is paying an FTE to do the scan to find what's vulnerable, right? It's a
But are you paying
quite a failure.
you to do the scan, or is it you just paying the AI company for tokens?
Regardless, like the company's paying. So uh, we go back to product liability laws. At which point do we want this thing to normalize in terms of who's we've had and we as at the three of us, like we discussed the changes at CISA a few weeks ago, right? Where is secure by default in all of this, right? And Tom, I just want to go back to the Star Trek references. I wouldn't mention those. I would go back to the hunt for Red October. Do you remember how Seaman Jones found the Red October?
Yeah. It
It-
was
for the-
he did not believe the computer
He
because the
did not
computer
believe
didn't
the
know what was
computer,
going on.
but what he did was he picked up so for those who haven't watched the Hunt for Red October, I highly recommend it.
Yeah.
Right, but sorry for the spoiler. There, one of the way that a very 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 clever sonarman finds the Red October, which is supposed to have a stealth propulsion drive, right? Is that he takes the sound and he speeds it up by a factor of 10, right? And then it becomes what was just a very low hum becomes a chuck, 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 which is obviously man-made, and that's how they find it, right? I mentioned this in the context of the way that we address these kinds of prompt injections and this type of bypassing or this this type of trying to gain the AI scanner is by having a second level scanner that doesn't watch for vulnerabilities. It watches for anomalies in the primary path, right? So if you, it's something that says, look, nobody's supposed to be talking about poetry, right? That's an anomaly. So how we compose these systems, right? It works in our favor too. It's not. Let's end this on a positive note. It's not just about attackers having lay of the land. It's that we can use these things for defense too.
So
Yes.
I'll leave you with this thought. The reason why we are where we are right now is because context is expensive.
Yes.
It's so if I ask you, have you ever seen The Hunt for Red October? The answer is easy. Yes or no, it's binary. But then I say why. That's the expensive part. So if we want to translate this into modern economics, the first part is easy, right? Detecting, is the vulnerability there or not? Why or how is it exploitable? That's where you're going to start burning tokens, is because you've got to provide the context. And that's why we have had such a hard time with this before, is because nobody likes yes or no. Nobody likes on or off. They want to know context. And for a human, context is actually fairly easy to provide because our brains are wired to do it. But when we're trying to replicate that system in electricity, in water usage, in token consumption, that's when we start seeing the actual cost behind it. And I think that that's the challenge that we're going to have to get over, is because we are always going to want to know why.
So I think that's the difference between just a scanner and an AI scanner. I think the autonomous nature of AI has to have the why built in, if you will.
Yes.
It can't just give you a scan result. It has to have the why built in. But, Fernando, you mentioned product liability laws. Product liability laws is what's reasonable for a product manufacturer to do to prevent an injury, to make sure it's a safe product, etc. That same reasonableness test, which is the test of negligence, will apply to owners of code who say, I don't want to know. I don't want to use the AI scanner. I don't want to know. I want to bury my head in the sand. And if something happens, I guess I'll find out. And then at some point, a jury is going to decide whether that was a reasonable risk and whether or not they're liable for someone's or many people's damages. And that's the way our system works.
And that's the way, and I agree, and that's where we're going, and that's where, like, perhaps I should stop talking economics and start talking law. I'm not a lawyer. I don't come from I come from a family of people in the legal profession. But yes, that's where we're going, and that's how this industry is evolving, and that's not necessarily a bad thing. It just means that we are now that much more strategic for society at large. Right?
Absolutely.
Let's embrace that.
I think we're going to go ahead and wrap it here, but please stay tuned for our law versus ethics episode, which will be coming up soon, because I just made a note that we're going to talk about that. But before we go, I want to make sure that everybody knows that these are two of the hardest working men in the industry right now, because they are writing so much stuff. Alan, I'm pretty sure you probably wrote a blog post while we were sitting here, knowing how productive you are.
I did pull it up, what I want for later. I did some of the ideas you and Fernando were talking about. I put them on this screen, and I'll play with it later. Unfortunately, in about 10 minutes, I have yet another video to do, but yeah, I will get to it.
Now, one of the other things I wanted to bring up here is Techstrong Gang has been doing live recordings. Like you've been broadcasting live. That's kind of exciting.
So we recorded this at 10 in the morning East Coast time. I'll be live on Techstrong Gang today at noon. I'm live on Techstrong Gang every day at noon. Monday to Friday.
Make sure you're tuning in for that, because those are some fun discussions.
Absolutely.
Fernando, what are you working on?
So we are just kicking off. So we just published in December our cybersecurity decision maker survey data, and I can spend 5 days talking about the data. We're just kicking off the new edition for that, so that should be coming in the April timeframe. Before that, there is all the excitement around covering the RSAC conference and what's coming around that. So that's what's occupying my mind right now. As of right now, my calendar for the conference is 99% full, kind of thing. But yeah, that's what top of mind. Plus, writing about all things AI, of course. I'm writing on AI.
I got one more thing I want to throw on the pile for people. By the time that people listen to this, we should have published our initial list of what we're calling the Quantum Security 25. The 25 leading thinkers in quantum security, post-quantum security. We're doing that in partnership with our friends at DigiCert. And if you think this AI stuff is crazy about security, wait till you see what quantum's going to do to it. And so go check that out as well, the Quantum Security 25.
I will remind you that if you want to see what quantum will do to security, I suggest you check out the seminal work Sneakers with Robert Redford.
That's a great movie.
I get to quote that and Hackers all the time, and people think I'm kidding, and I'm not, because believe it or not, Risk Architecture really did change everything. Thank you, Angelina Jolie.
These movies were ahead of their time.
Well, we hope that you enjoyed listening to this episode, because I had a lot of fun recording it. But if you did, we would love it if you join the conversation. Check out our YouTube channel and maybe download this in your favorite podcast application of choice, like if you're running or mowing the lawn or whatever it is you do in your spare time. But when you do one of three things for us. Leave us a rating, leave us a review, or leave a comment. Agree or disagree. We just want to have some fun discussion going on because that really does help the show grow. This podcast is brought to you by securityboulevard.com and the Futurum Group. If you want to check out show notes and past episodes, securityboulevard.com is the place to go. You can also check out the Techstrong TV website or the Techstrong TV app. I'm trying to get it running on an old iPod video. Check in for the results, but if you have any other smart device, I'm sure it'll work on that. Apple TV, Roku, iOS, Android, you name it. We will also want you to check out Security Boulevard on X, Twitter, and LinkedIn. The handle is SecurityBLVD, and there's a lot more content that you want to check out there. We want to thank you all for tuning in. We'll check you all out next week.
I'm Ted Weatherford. I'm VP of Business Development. I've joined with John, who's our distinguished engineer and architect on our E-Series products.
Nice to be here.
Yeah, and I'm going to cover the X-Series products now. The X-Series product is a Ethernet switch, and what distinguishes it from all the other Ethernet switches, literally, is that it's programmable. And its programming model is a load store type model. You have 3,072 little Harvard architecture cores inside this Ethernet switch chip. All the competition is approaching the problem with a fixed pipeline. They may call it programmable, but at the end of the day, it's a fixed VLIW pipeline with fixed elements and programmable elements, and it has a fixed latency, and you don't have the flexibility to do tasks in parallel. What we've done is run a complete model with this 3,072 little Harvard architecture cores, and it gives us two things. It gives us more flexible than any Ethernet switch chip that's available or has ever been designed, with an actual architecture I'm showing here that allows us to scale down or up really gracefully. To call it an FPGA, because it kind of looks like an FPGA floor plan, would be a complete misnomer, but it is symmetric. And if you look at all the little squares, there's 64 of them. And each of those 64 squares has 48 processors. Okay, and they're run to complete. So when you go to program this, you're not forced into a pipeline, okay, of sequential steps where you write the code, you turn the code 90 degrees and you drop it into the pipeline. You literally can do recursion. You can do whatever you do within your instruction space and the time you have for the minimum packet size. We've sized all the caches. We've sized all the clocking so that you have this amazing low power device with tons and tons of header processing. You can do 11 layers of MPLS, for instance. So all kinds of IP inside IP, any kind of encapsulation, whether it's already a standard or something that's developed. And I'm gonna, yeah, thank you.
Ultra Ethernet, things like that. These sorts of things that are starting to come out of the woodwork. UA Link, I'm guessing that's UA Link here, but how does that play in this space?
It's exactly where this shines. And for Ultra Ethernet or ESON or some of the Ethernet-centric extension protocols that are coming out for AI, we're there. We can ship this. And some of the physical layer mechanisms, like the layer 2 retries, there's things in there that we didn't catch with this particular tape out, but protocol-wise, congestion management-wise, the in-flight packets for the servo loops, for all your congestion management, all that's dialed in and completely flexible. You can build your own server for any scheme. So it's ready for that better than all the other products because they're fixed in function. And that was the one exception, is the retry. And then on the UA Link reference, this is not a UA Link switch. That's correct. It's not. I'll just offer the latency of this switch while we're at it. A UA Link is a very low latency switch. It's back-end scale-up centric. This is a front-end scale-out or a back-end scale-out a product. And we can get down to, 450 nanoseconds, which is screaming for a traditional scale-out switch. I mean, your Broadcoms are at 800 when you really measure them. So one of the advantages of having a run-to-complete architecture is you can dial in the latency to be as good as it gets.
So Ted and Jack Poller with Paradigm Technica, can you talk a little bit more about run to complete and what that means for you?
Yeah, thank you. So there's really 3 different architectures. There's a von Neumann, a Harvard, and of Dataflow. And run to complete speaks to an architecture where you have an instruction set that you're running, right? And you'll run till you complete the overall operation of the packet frame coming and being modified and being sent out. So the frame shows up, Ethernet, it gets modified, it gets shipped on its way. And what run to complete allows you to do is have complete flexibility. You don't have to handle the packet one piece at a time sequentially. You can move around to anywhere in that packet header or that packet within a window. So the run to complete is a amount of time or clock cycles you have to do work, but that work does not have to be only sequentially. That's my level of understanding. Yeah, it's more flexibility and it allows you to do things in parallel. And there are many packet operations that can be done in parallel. So you end up saving time and getting latency from it and not being caught off guard if protocols change or you have something interesting. Where it really matters, because all of us use standards, right? It matters with all of the instrumentation and telemetry. The observation and the troubleshooting of these networks is getting increasingly complex. And this kind of model just allows you to build the best instrumentation and telemetry with really less constraints. So it's symmetric and it'll scale either way. So each one of those blocks is a 400 gig block. So if I want to go build a 400 gig, a tiny little switch, I just do one block. If I want to scale up to 400 terabit, and I shouldn't have said that number, then you increase the block size. So it does have that sort of geometric scaling up and down in this graceful, symmetric way, which you won't see when you look inside the fixed function data center switches. You'll see pipelines, and they're fixed in nature, and there's a number of them. I'm not going to cover this. It's an eye chart, but I want to point out that we have large amount of packet buffer. We're very low power. We sell the 12.8T in derivatives. It's the same die, but we downclock it. You can turn the SerDes down. The SerDes can be all different speeds. So we're software defined even at the physical layer. You can have SerDes coming in at 100 and going out at 25 with different modulation schemes. You can mix and match. And this is actually really, really, really sexy because you've got these new fabrics up there with 100 gig SerDes that have just been deployed last summer, and they'll be around for a while. And then downward, you've got all the legacy. So you can run it 10 gig, 25 gig, 50 gig, 100 gig, 200 gig with whatever SerDes and whatever modulations you want. So it really gives you this building block for looking backward as well as forward. People ask us, why do we only do 12.8? It's because we're going after the edge, and I'll cover that later. We're going after half rack, full rack, 2 rack. We're going after satellites. We're going after base stations, okay? The performance is there. The chips are here. The boxes are out by our Taiwanese friends, Acton and EdgeCore. You can just measure everything, but you got to show people some performance if you're claiming to be programmable and lower power than a Broadcom or an NVIDIA or a Cisco or a Marvell. So we do that. And that's what this is. It's the watts on the left, and it's breaking down the SerDes, the core, and it's showing what your max and mins are over that. And this is crazy to have a 12.8T switch that's programmable at under 200 watts. It's disruptive. This is showing you efficiency of the most important thing about a switch besides its radix. Switches are connectivity at the end of the day, and how much bandwidth and how many different connection points or ports you can have. But the other thing that matters, and it really matters, is the shared memory or not buffer, the frame buffer. The packets come in, and do they come in fair? And can you utilize, in times of burstiness, can you utilize the whole buffer that you paid for without overrunning it? So in our example here, we take 127 ports running at 100 gig each, and we ram it out 100 gig port, and we find out how long till the packet buffer fills up does it overrun. And then we do it, at the different oversubscription rates and different packet sizes. And we show that the utilization never drops below like 86 or something. And in real world tests, that's amazing. Okay. So if you're a switch head like I am, then you're like, oh, wow, that's amazing. The Tomahawk products that are dominating the market.
Ted?
Yeah.
Ray Lucchese, Silver Nickel.
Oh,
Still trying to get a handle on this. You're not actually manufacturing DPUs. You're actually manufacturing the chips that would go into DPUs or chips that would go into a switch.
We have two products. They're both chip products. I'm covering the switch first. It's a separate tape out, and it's just an Ethernet switch chip with 128 100 gig SerDes on it. It's a switch chip. Next, we're going to cover our ESERs, which is a DPU. So we have two products. It is amazing. 200 engineers doing two products of this complexity it's a lot. So we have two chips. They go together nicely. They have the same SerDes IP. They play really well together because the highest volume opportunity is the top rack and the front end interface or the back end interface into the server or the GPU server. And so we bookend that with these two products, especially for the edge. We're a chip company, two chips. I'm going to pick up the pace a little bit. This is showing the fixed pipeline and the map pipeline approach, which is not ours, against this run to complete full SDN. We can imitate the other architectural approaches. They can't imitate us. So we can make the trade-offs between latency or the amount of work you're doing and the amount of power you're spending. So this is more of a deep dive for somebody that wants to compare these products to data flow architectures or fixed function stuff. But suffice it to say, we're trying to say that you can have multiple pipelines, you can have branches, you can have a physical connection and a logical connection that's flexible.
Challenge with something like this in the past has been latency. I mean, to do something that's not pipeline or not map pipeline and achieve the line speeds has always been impossible before.
We're proud of it. Yeah. I'll give you a clue. If you're designing for your worst case and you're building a pipeline, you've got a lot of stages you don't need. If you build with us and you put our 3,000 processors in a line, if you want to pretend it's a pipeline, you can, and you'll just have less instructions, or you could have one processor handle a whole packet. You can build a pipeline like they do, or you can have one processor handle one flow. You have this whole range.
I guess the question is, what's the clock speed, and how fast are you able to maintain line speed across however 128 ports? I guess.
Yeah, it's 128 ports at 128 byte minimum packet all day long till the cows come home, with a maximum power of 186 watts at 12.8. It's mind bending, and I can just say that the team is basically on their 8th or 9th generation network processor or switch when you combine the people. We have people from Motorola, Freescale, NVIDIA, Broadcom, Juniper, Cisco. It's a pretty senior, strong team that's been doing network processing, DPUs, and switches for, 30 plus years. Yeah. No, it is, before we had the products, it can be a lot more interesting debate. Now we just have the products. So you can just put them on the test and test. In fact, we have built-in self-tests that we don't advertise, but that's a really nice feature we have too. You can run 12.8 terabit of line rate. Every port has its built-in Exia tester. So you can even test the device in its own printed circuit board without an expensive $3 million tester. So programming model is always the challenge for programmable products. We have an assembler that we've wrapped in Python, and we provide libraries. You've got to configure the tables for forwarding, the tables for security, the tables for quality of service, the meters, the counters. You have to set all that up, and their structures, and we have libraries, and you have to program this thing in our assembler. However, we opened up the instruction set, and our first customer, which we did a PR on, called Oxide, they're a local cloud guys, you know them?
In the field,
They wrote a P4 compiler on it. So this is a simple risk instruction set. I shouldn't call it risk. It's technically a Harvard architecture, but it's a small little instruction set that you'll be familiar with if you're a programmer, especially somebody that really programs deep, and they just wrote a compiler on top of it. So our whole ethos is it's open, do what you want, and we also have plans of putting out a P4 compiler early next year also, because we have a lot of customers that really want that higher level, or what I would call fourth generation language. It's kind of dated terminology, but so today we give you courses, we've got all the examples, and we haven't had a customer we had to write all the code for. They've all taken the classes and written the code and done quite well. And one of them is, I'll foreshadow, is SpaceX. So we're really excited about that. The architecture and the normal stack of what you target to, on the very bottom, I'll start there. You've got the switch device. That's what you really care about. But you can also do simulators, and you can also do hardware emulators. We built our own hardware emulator. We have a room full of FPGAs of design we did ourselves. We do all our own hardware emulation. We don't buy hardware emulators. We have our eval boards, which are just rack systems, pizza boxes with front panel ports like you'd see in a top of rack switch or a fabric. And then this just shows the network operating system down and what we provide. And we put all this, on open. Anybody can get to it. And the network operating system of choice for all of us now is Sonic. And we do our own Sonic distribution. And then we have 2 partners that provide hardened Sonic as well. So that's what your normal stack looks like. And this is what a box looks like. I have it right over here. I just want to say it's real. It's available. This particular one is what we call the universal switch, because the MPA connectors are QSFPs, and you can put whatever you want in them. Each little rectangle is 4 SERDES, and those SERDES can run at whatever speed you want. And there's common media for 4x25, 4x50, 2x50, et cetera, so that you can build a top of rack here, which we call a top of rack upgrade or a TOR upgrade, so that, again, you can connect to any kind of speed up and any kind of speed down. You can migrate from older network interfaces to newer ones, or maybe one storage box has a certain kind of thing and it's in the same rack with a server or a GPU server.
Got a question.
Yeah.
Specifically about the TOR here. Do you think, and you can theorize here a little bit, do you think once 224 SerDes comes around, you'll be able to stick with the same form factor, low power, and not go liquid cooling?
Depends straight up on how much bandwidth you want.
Straight on bandwidth.
If you did a 25.6T, you could stick with this.
Yeah.
A 51.2T would be harder.
Yeah.
It'd be harder. That I'd have to defer to a switch expert. But that's the answer.
Okay.
No, yeah.
Maybe 51 too, but
yeah.
But,
and our architecture is really on par at a geometry level with the others. So if we do a 100 terabit switch,
right,
it's gonna be 1,000 watts.
Yep.
So what we've done to just be so disruptive on power now, full disclosure, is we went to 5 nanometer when everybody else was
still in the old days. Yeah.
was going forward with very large rating switches, and we did it to capture the edge, the economics of the edge, the power of the edge, and the right amount of connectivity for the edge. I got an example on that coming. I'm going to just move faster. We built this for a large hyperscale for this exact thing. Their particular format is just a different cage. This is a 16 by 800. So that's the TOR they happen to use. And this gives them a benefit of half the power, half the rack space, a quarter of the cost.
That product was GA24?
Yeah.
So how long has this puppy been out there?
We first sampled this April of 2024, and we called it generally available. Both our products have been first spin, no metal spins to market. We called it generally available in November of 2024, and it's been in mass production since summer of 25. Yeah. No, this is out there.